Hello my friends, today we are going to learn about the types of digital modulation. First we'll see the introduction of this. The contents are Introduction to Communication Systems, that is the basic two types are there, analog modulation and digital modulation techniques. Under analog modulation we can see that the basic three types are amplitude modulation, frequency modulation and phase modulation. Under digital communication systems, amplitude shift keying, frequency shift keying and phase shift keying. Actually the other basic types are phase quadrature modulation, that is the QPSK, quadrature phase shift keying. But we'll see the basic types today only. So we'll see first that what is the introduction to modulation and demodulation. From the analog modulation techniques you must be knowing that the purpose of a communication system is to transmit information from a source to a destination. See, as shown in the figure here, digital or analog signal, it is passing through the encoder. After the communication channel or through the communication channel, the decoder will be at the demodulation system. It will be decoding the signal here and will get the output like this as the digital signal here. So that is the encoding process we can say. In the modulation process, the modulator will remove the carrier signal and after demodulation we are getting the original signal here. Now what is modulation here? In modulation, a message signal which contains the information is used to control the parameters of a carrier signal so as to impress the information onto the carrier. So what these messages are? These are nothing but the modulating signal and these are either analog type or digital type. The carrier is nothing but the sine wave or a pulse train. So in case of pulse modulation systems we are using the pulse train. Consider the sine wave carrier. ASK modulation can be represented by the following equation: S of t equal to A cos 2 pi fct for binary 1 and S of t equal to 0 for binary 0. If the message signal m of t controls amplitude, then we are saying that it is amplitude modulation. If the message signal controls the frequency, it is called as the frequency modulation. And similarly, if the message signal controls the phase, it is nothing but the phase modulation. So depending on these three types, in case of amplitude modulation, phase modulation and frequency modulation, in analog modulation systems, we are seeing these types of the waveforms whatever already you have studied under the analog communication systems. So this is the carrier signal. Below one is the modulating sine wave signal. Below that the amplitude modulated signal here, which is DSBTC, that is double sideband transmitted carrier. Then phase modulated wave and here the frequency modulated wave. Similar to that, in case of digital modulation systems also, we are having three types, that is amplitude shift keying, frequency shift keying and the phase shift keying. In this discussion, the binary signal is having two levels, either 0 or 1. So for binary FSK, we are representing the signal as S of t equal to A cos 2 pi f1t for binary 1 and A cos 2 pi f2t for binary 0. Binary PSK can be represented by the following equation. If S of t equal to A cos 2 pi fct for binary 1, then S of t equal to A cos 2 pi fct plus pi for binary 0. The types of modulation produced, that is ASK, FSK and PSK, are sometimes described as binary or two level. That means BFSK and BPSK. So we'll see the waveforms for this. Consider this as the digital signal. So for ASK we can say that when the binary data is 1, the carrier signal is transmitted here. When the binary data is 0, the signal will not be transmitted. Similarly, see here, for binary 1 the signal is transmitted and for binary zeros no signal is transmitted. In case of BFSK, that is binary FSK, we can see over here that the frequency will have two values, say f1 and f2. F1 for binary 1 and F2 for binary 0 signal. So these can be interchanged according to the user requirement. The third type of the modulation we can see here is the binary PSK. So here again we can see differentiating the two phase shift here. Either it is the 0 phase shift or it is the 180 degree phase shift as shown in this particular waveform. So for 0 bit I can say that there is 0 degree phase shift for the carrier, and for 1 bit we can say that there is 180 degree phase shift for the carrier signal. So in this way we can differentiate the ASK signal, BFSK signal and BPSK signal. So which is amplitude shift keying, binary frequency shift keying and binary phase shift keying. Now the next part we'll turn is what is demodulation. So demodulation is the reverse process to modulation and to recover the message signal M of t or D of t at the receiver. So thank you friends.